On 18th June 2023, Titan, a submersible operated by the company OceanGate, imploded during an expedition to view the wreck of the Titanic in the North Atlantic Ocean off the coast of Newfoundland, Canada. Initial design work indicated that the hull, to be rated for 4,000 meters depth with a 2.25 safety factor, should be 114 millimeters thick or 4.5 inches, which OceanGate opted to round up to 5 inches, 127 millimeters, to build in an additional safety margin. In engineering design, two important design loads need to be considered for such a high-performance structure. There is first the limit load, which is the maximum expected operation load. In the case of the Titan submersible, this would be a load of 40 megapascals at a depth of 4,000 meters. The second design load is the ultimate load, which is defined as the limit load, multiplied by a safety factor. Degradation of composite materials, subject to cyclic loading, is a multi-step process involving micro cracks, formation and progression until failure occurs, implosion in this case. For composite structures such as the cylindrical hull of the Titan, it would therefore be smart to also define a third design region as reserve. The safety factor for the Titan is 2.25, according to an article from the website compositesworld.com. There are several aspects which are considered by a safety factor, for example. 1. Buckling. 2. Variation of material data. 3. Variation of wall thickness. 4. Effect of temperature on mechanical characteristics. 5. Adjacent structures influence. The design of cylindrical composite hull is probably the cause for the implosion of the Titan. Carbon fiber reinforced polymer, CFRP, is the composite material from which the Titan was built and is usually well understood. However, most calculation methods only work well for thin composite structures, and the Titan with it, radius of 840 millimeters and its thickness of 127 millimeters, is considerably thicker than most design rules are valid for. First estimations on the available data of the Titan lead to a design load of 70 megapascals. This is the expected material failure load according to finite element simulations. The 70 megapascals, however, is without consideration of any of the before-mentioned safety aspects. The onset of degradation, which is important for cyclic loading, occurs in the safety region, which is usually forbidden. If buckling is considered, the design load reduces to about 52 megapascals, which should still be safe, but overall, the safety requirements for a manned high-performance structure are not fulfilled. In order to achieve at least the stated safety factor of 2.25, the wall thickness should have been increased by additional 55 millimeters to a total thickness of 182 millimeters or 6.65 inches.